Hi guys, and welcome to another math video, this time on multiplying and dividing surds. We continue on with our system or the previous videos. Now, if you haven't already tuned in, there are a couple of videos before this explaining what a surd is and explaining how to add and subtract these things before we get to multiplying and dividing. If you are new to my channel or my website, hey, it's really good to see you. If you can subscribe to me on YouTube, just lets me know you're watching. I'm never going to be rich and I am never going to be famous. And if you're over on my website, that's awesome because you got downloadable notes, lessons and videos are all ordered by textbook and so much easier to find than perhaps on YouTube. All right, what are we doing this lesson? Our learning objectives are to understand how to multiply and divide surds. As I say in the previous video, yes, we were guns at adding and subtracting. We learned that we could only add and subtract when they were like surds. So for example, we could only do 2 root 3 plus 3 root 3. Those surds there are the same, they're like surds, and so that would become 5 root 3. Yep, because I'm doing the 2 and the 3 added together. I've got 2 somethings plus 3 something. We tried to say that we were going to try and trick you because we could do 2 root 2 plus the square root of 8. And you've always got to check for every single surd that you do that you can in fact simplify or see if you can simplify any of them. This is not necessarily going to be as helpful in multiplying and dividing surds because there are rules behind this that don't necessarily, and again, if you go out to fractions, if I do a half plus a third, that's relatively challenging. Why? Because we don't have the denominators that are the same, so we have to use a load of processes to do that. In the same way as if I did a half times a third, that's much simpler. So multiplying and dividing surds is actually freaking awesome. We're going to extend it a little bit by applying the distributive law to brackets involving surds. As a recap, if we remember, what we do forwards in maths, we can always do backwards, yes? So realistically speaking, it's the same. Anyway, new discussion. We've looked at the idea that if we have the root of xy, that can be split up into the root of x times the root of y. This is going to become really important to me, but it's also the same in reverse. If I have the square root of x times the square root of y, it becomes the square root of x times y. Likewise, for division, we know that if we have the square root of x on y, that's the same as the root of x divided by the root of y. Or we can reverse it. So remember, if I have the root of x divided by the root of y, I can now combine that into one particular rule. This is the stuff of legend. Maybe not. So I suppose the best idea here is just to jump into some examples, and they don't get particularly complicated. This is more a test of your multiplication and whether you can remember just another set of rules. So we have root 2 times root 3. Well, if you remember, we've got a root times a root, so that becomes the root of 2 times 3, which is just root 6. Thank you very much. Can I simplify that? No. And again, please remember that you may be able to simplify these things once you've done this multiplication, but root 6, I can't. I've got 2 root 3 times 3 and root 15. Right, so in this situation, because if you remember, multiplication 1 times 2 times 3 is the same as 3 times 2 times 1, which is the same as 1 times 3 times 2. When everything is multiplied together, we can move them around. It's part of the rules again. God, this is so rules-oriented. So in this situation, I can actually think of this the same as 2 times 3 times root 3 times the root of 15. All right, all I've done is move this 2 and the 3. I'm going to multiply those together. That gives me 6. And then I have root 3 times 15, which is the same as 3 times 15 under the same root sign, which gives me 6 root 45. Can this go any lower? Well, let me think. We've got 1, 4, 9, 16. Hold on, 9. 9, 18, 27, 36, 45. 9 goes in there 5 times. So we've got 6. And I've got 9 times 9, 18, 27, 36, 45 times 5. It becomes 6 times 3 times the root of 5, which gives me 6, 12, 18 root 5. Could we have simplified this anywhere? I've got root 15, 1, 4, 9. So I couldn't, but I could do the 15 when it was multiplied by the 3. Sorry, guys, not feeling my best today. Got this awful cold, but by the time you're watching this, it probably won't matter. If we go to the next one, now there's a rule here. I'm just going to rub this out, so hopefully you don't need this for the notes later on. We know that AB all squared is the same as A squared, B squared. So basically when you square a series of things inside a set of brackets, as long as they're multiplied together, you square each individual term. So if I have 2 root 5 all squared, then that's the same as 2 squared times the square root of 5 all squared. And going back to a previous video, if you remember, when you square root a square or square a square root sign, they effectively cancel each other out. So 2 squared becomes 4. The square root of 5 squared just gives me the 5. And so that gives me my beautiful answer of 20. All right, so division is a tricky one. But again, it's not tricky in the sense of what you're trying to do, because there's just a rule. But it is tricky when you have something like 2 root 5 divided by 10, for example. Now, that's not a massive trick, but you've got to realize here that where you have a number on the top and a number on the bottom that is outside of the root sign, you must try and cancel it where you can. So in this situation, if this was my final answer, that would become 1, that would become 5, because 2's go into both of those, and so I would get root 5 on 5. Now, sadly, lots of people do this. 2 root 5 on 10, they go, oh, I can see a 5 and a 10. A 5 here goes into there twice, 2 into there goes once, and I get 1. Horrible. You're not allowed to do that. That square root sign is very different. It protects the 5 underneath it, and so it can't be divided in. So I'm going to get rid of this example just so that no one out there hopefully thinks that's a good idea. Right? The basic rules of fractions apply. Right? So when you cancel down, you must. Maths is a huge trick. Barry is going to trick you. And wherever we write things in a slightly different way, you can guarantee it's some sort of a trick. So for example, if I had a to the power of 6 divided by a to the power of 2, we never ever write the divide signs. All right? Not normally, unless it's trying to trick you. Because we know that if we wrote a to the 6 on a to the 2 like that, then the chances are you'd understand, hold on a moment, I can cancel 2 of the a's there, and I've got 4 of them left, job done. If I write it like this, sometimes people go, oh, hold on, that's the subtraction of indices. So that gives me a to the power of 4 as well. There's lots of ways of doing it. But generally speaking, I think if we do a divide sign, pretty sure it's trying to trick you. And so here, if we have the root of x divided by the root of y, just realize that's the same as the root of x divided by the root of y, and we know that that can become the root of x on y. So pattern spotting in the questions is really, really important. If you can look the question and see what it is they're trying to trick you with, write it in the format that you're happy with. The rest of it should be child's play. All right, so look at that, minus the root of 10 divided by the root of 2. Well, I'm going to write that in a slightly different way. Minus root 10, and I'm going to divide it by root 2. Now, positives and negatives, whatever, that stays because I've got a negative on the top and a positive on the bottom, and so when they divide it stays as negative. I am now going to separate this, and that's just going to write that as 10 on 2. I suppose separate wouldn't be the right word really. I'm going to combine it. That's better. And now where I can simplify, I must. I know that 10 divided by 2 is 5, so that is simply the square root of 5. Ka-ching! Thank you very much. And then we get the next question. And again, all the questions you get are just going to be a variation of this. So we have 12 on root 18, 3, root 3. So the first things I'm going to do is, can I divide the top and the bottom? Yep, 3 is going to there once, and 3 is going to there 4 times. But that is not the end of my question. Because while I can't simplify the root of 3, I should probably believe that I can square root 18, or I can simplify the root of 18. So that becomes the root of, now that's 9 times 2 divided by root 3 on the bottom. All right, so all I've done is I've turned the 18 into 9 times 2. The root 3 on the bottom is what was left. So that becomes 4 times the square root of 9 is 3 times root 2 divided by root 3, which gives me 4, 8, 12, root 2 divided by root 3. Now again, don't get tricked. Although there's a 3 here and a 12 there, they can't divide each other because that square root protects them. And there is my final answer. Now in many cases, sometimes you'll get a root on the top then that can cancel with the root on the bottom. Not in this situation. I'm just going to leave that answer exactly where it needs to be. The distributive law is freaking awesome because, well, you should have been doing this in year 9, and depending on where you are in year 10, you may have already been doing this with quadratics or just factorizing or expanding brackets. So the distributive law states, if you have a set of brackets, whatever is outside the set of brackets must multiply everything inside that set of brackets. So what we're saying here is we've got B plus C times by A. The A multiplies by the B, which gives me AB, and the a multiplies by the plus c, which gives me plus ac, and effectively that's the distributive law. And that can work with surds as well, and there are going to be examples in a moment. So for example, if I have root 3 times root 2 plus 4, for example, that is the distributive law. I've got root 3 times root 2, so I'm going to do this times this first. Well, building on the knowledge I've got from the start of this lesson, that becomes the same as root 6, because the 3 times the 2 becomes the 6, plus, now, is this 4 under a square root sign? Nope, so I can't use that rule. That becomes 4 root 3, all right? So because I've got 4 lots of root 3. Can I make this simpler? Nah. Can I add them together? Nah, because the square roots aren't the same, and it all starts to build in. One of the other tricks we use in maths, and I did a very simple example there, was again where we have this 3 and the 4 outside the bracket. Just remember that when you do that, that's the same as 3 times 4 times root 3 times root 2. We can multiply the numbers outside those brackets, or outside the square root signs first. So 3 times 4 is 12, and then root 3 times root 2 gives me root 6, and so my answer becomes 12 root 6. This all comes down to practice. The more you practice this stuff, the better and better and better you'll get. I promise you. So here we go. We've got this first example of root 3 times 3 root 5 minus root 6. Okay, so root 3 times both of this. Well, is there a number outside the root 3? Well, yes, theoretically 1, but I'm just going to do that 3. So 1 times the 3 outside gives me 3, and then I'm going to multiply the roots together. So I've got root 3 times root 5. So root 3 times root 5 is root 15. I'm going to put a minus sign. Why? Because that's a minus, and this is a plus. And so a minus times the plus is a minus. And again, let's get rid of that 1 because it's tricking me or it's confusing me. And in fact, that dot was a stupid idea. Root 3 times root 6. Well, in that situation, I can do that. Give me root 18. Is that the end of my answer? No, it is not, because can 15 be simplified? Let me see. 1, 4, 9. Nope, nothing going to that. So that stays as root 3 root 15. What about that one? Well, that can become 9 times 2. Yes, indeed. So it becomes 3 root 15 minus 3 root 2. And I can't simplify that, can't subtract them, because the root signs are not the same. What about the next one? So I've got 3 root 6 multiplied by 2 root 10 minus 4 root 6. Now this is building up into something coming a bit later on that's a bit of a trick in maths, but a bit of an awesome thing to learn as well. So let me see, I've got the 3 times the 2, which gives me the 6, and I've got root 6 times root 10, which gives me root 60. Let's get rid of these lines underneath now. I've got minus 3 times 4, which gives me 12. Now, this is where life gets interesting. Root 6 times root 6. If I have root 6 times root 6, that's going to give me root 36, which is just 6. And if you remember, there is another way of writing root 6 all squared. When you multiply something by itself, you're actually squaring it. And what does a square and a square root sign do? Gets rid of it. All right, so that just becomes 12 times 6. Right, okay, can root 60 be cancelled down? 1, 4, yes, 4s go into that. 9, 16, 25, so 4s. It becomes 6 times, right, 4s into there go 15. Minus 12 times 6. Now there's no root sign there, okay, so it's just 12 times 6, which is 72, which gives me 6 times 2 times the square root of 15 minus 72. Keep wanting to write square root signs because my brain is screaming at me to do so. 6 times 2 is 12, root 15 minus 72. Can I subtract those? Nope, because one's got a square root sign in it and one of them hasn't, so it's not a like term as such. Can I simplify that in any way, shape or form? No, root 15 stays as it is, and ladies and gentlemen, there is the distributive law and surds. And I'm at the end of this video as well. Wow, this is going quickly today. Thank you so much for watching. As I say, if you can head over to MaffsGuru.com, that'd be greatly appreciated. Why? Because it's got lesson notes and it's got videos and it's all searchable. It's my textbook. And otherwise, if you can head to YouTube and subscribe, it just lets me know you're watching. Otherwise, I'm done. Thank you very much. Have a good day. Hope to see you again soon. Stay safe. Bye-bye.